Hi everyone. Now we are discussing about the area network analysis and synthesis. By using this network analysis and synthesis, we can simplify or we can analyzing the complex circuits. So analyzing the complex circuits means from that complex circuits or networks, we can find out the unknown voltages, unknown currents and unknown power delivered to the particular circuit. So under this network analysis and synthesis area, it is having different types of techniques and different simplification methods to analyze the circuits. So in that one of the method is mesh analysis. So let us discuss about mesh analysis. So mesh analysis. So first of all, what is the definition for mesh and how to perform mesh analysis and why we are using mesh analysis in electrical network. So further, to analyze any basic electrical network or the given network, our aim is to obtain power delivered and power absorbed in different elements. So the power is nothing but product of voltage and current. So to get these values, definitely for any circuit, we can determine the unknown voltages and unknown currents. So here this mesh analysis is used to obtain the unknown current present in electrical network. So coming to this definition for the mesh is defined as a loop which does not contain any other loops within it. Means mesh is a loop which does not contain any inner loop. That is the mesh. And mesh analysis is applicable only for planar networks. So planar network, nothing but it is defined as it is having or it is drawn on a plane surface without any overlaps or crossovers. And it will not applicable for non-planar networks. And if your network is having more number of voltage sources, it is useful to use mesh analysis. So mesh analysis is used whenever the given network contains more number of voltage sources. And so we can find out these unknown mesh currents by applying Kirchhoff's voltage law for the mesh. So basically, this analysis consisting of writing mesh equations by using the KVL in terms of unknown mesh currents. So to determining the currents, we are using KVL and writing the mesh equations and analyze the circuit. Next steps to be followed in mesh analysis. So the first step is identifying the total number of meshes in the given electrical network. Second one is assign the mesh currents. And third one is develop KVL equation for each mesh. And fourth one is solve the KVL equations to find mesh currents. So first one, from the given network, how to identify how many number of meshes are there in that given electrical network. Next, for each mesh, you have to assign the mesh current. And for each mesh, you have to write the KVL equations. So after writing all the KVL equations for that meshes, further finally we'll solve those KVL equations and determine the mesh currents. So let us discuss one example, one problem. So here the problem is find the current through 2 ohm resistor of the network shown. So this is the given network. In that, how to determine in the current passing through this 2 ohm resistor. So to solve this problem, the steps to be followed are first of all identifying the total number of meshes. So in the given network, first identifying the number of meshes. So this is the first mesh and second mesh and third mesh. Mesh is nothing but it is a closed loop which does not containing any inner loop. So that's why this is taken as mesh. This is also another mesh. This is also another mesh. And second point is assigning the mesh currents. So each mesh assigning the current either in clockwise direction or anti-clockwise direction. You can choose any direction. Generally, here I am considering the clockwise direction. And develop KVL equation for each mesh. So develop KVL equation for the each mesh. And final step is solve this, analyze this KVL equations to find the mesh currents. So see here, in this problem, it is having three meshes, 1, 2, 3. And for each mesh, I assign the current in clockwise directions. So first mesh current is I1, second mesh current is I2, and third mesh current is I3. So, and third step is apply KVL for the each mesh. So here I am applying the KVL to the mesh 1. So, and the current is passing in clockwise direction. So, it is entering into this 10 volt source. So, this is the negative terminal and this is the positive terminal. So, consider this is the positive value. So, 10 volts. And here the current is entering in positive terminal, leaving it negative terminal. So, consider this is the negative value minus 6I1. And if you observe, the current passing through this 1 ohm resistor is I1 and I2. So the net current flowing through this 1 ohm resistor is minus of I1 minus I2. So if you observe, the I1 current is passing opposite to the I2 current. So those two are in opposite direction. So that the net current flowing through this 1 ohm resistor is minus 1 into I1 minus I2. So this is for the KVL for the first loop. And next, applying KVL for the second loop. So in this also, the I2 current is passing clockwise direction and in this 1 ohm resistor, two currents are flowing, I2 and I1. Those two are in opposite direction, opposite each other. And in 3 ohm resistor also, I3 and I2, both currents are passing opposite to each other. So write the equation. So minus 1 into I2 minus I1 minus 2I2 minus 3 into I2 minus I3. So that is the equation for mesh 2. So minus 1 of I2 minus I1 minus 2 I2 minus 3 I2 minus I3 equal to 0. So that is the KVL for the second mesh. Next applying KVL to the mesh 3. So here consider this 3 ohm resistor. In this 3 ohm resistors, two currents I2 and I3 both are passing opposite to each other. So minus 3 I3 minus I2 minus 10 I3 and here positive terminal and negative. So minus 20 is equal to the 0. So this is the KVL for the third loop. So finally by solving those three equations we can determine the three unknown values. Those are I1 and I2, I3. So our aim is to find out the current passing through this 2 ohm resistor. That current is nothing but I2 current. So 0.62 amperes is the current passing through 2 ohm resistor. So this is the way to find out the unknown currents present in the given electrical network. Thank you.